Okay, let's finish up section 2.7. Our first reminder is when two lines intersect, pairs of vertical angles and linear pairs are formed. That gives us another postulate. Postulate 12, the linear pair postulate. If two angles form a linear pair, then they are supplementary. Angle 1 and angle 2 form a linear pair, so, oops, need a pen, sorry. Okay, angle 1 and angle 2 form a linear pair, so angle 1 and angle 2 are supplementary, and the measure of angle 1 plus the measure of angle 2 equals 180 degrees. Theorem 2.6, vertical angle congruence theorem. Vertical angles are congruent. Okay, this is the one that I keep wanting to use with you guys, but I hadn't taught it to you yet, so I couldn't use it. And all this theorem tells us is that angle, oops, let me turn the pen back on. Angle 1 is congruent to angle 3. Angle 2 is congruent to angle 4. And remember, congruent means that the shapes or the diagrams, the drawings are the same, not necessarily the measurements. We have to change that to the measurement of angle 1 equals the measurement of angle 3 using the definition of congruent angles theorem. Or sorry, the definition of congruent angles. Get that one straight. Okay, let's use this. Prove the vertical angles are congruent theorem. Prove vertical angles are congruent. So given angle 5 and angle 7 are vertical angles, we need to prove that angle 5 is congruent to angle 7. So what do we know? If you guys want to write this drawing down and turn to the next page, I'm going to prove it. But there's not enough room on this slide. All right, let's get this started. Let's write down what we know. We know that angle 5 and angle 7 are vertical pairs. Vertical angles, I'm sorry. Okay, and that reason is given to us. What else we know? If we go back to the diagram, we know about linear pair. We know that angle 5 and angle 6 are a linear pair. We know that other one's a linear pair too. Angle 6 and angle 7 are a linear pair. Cool. Okay, what's our reason there? Okay, our reason is the definition of linear pair. We see that in the diagram. We can interpret that diagram because we know that they're vertical angles. Vertical angles are made by intersecting lines, and a linear pair uses a line, an array, to form a linear pair. All right, what else do we know? Well, we know that linear pairs are supplementary. So we have angle 5 and angle 6 are supplementary. And also angle 6 and angle 7 are supplementary. And we know that because of that linear pair postulate. Okay, linear pair postulate says, linear pair are supplementary. They add to 180. All right, so I'm going to go back and read the congruent supplement theorem. Congruent supplement theorem says if two angles are supplementary to the same angle, then they are congruent. So I have two angles supplementary to the same angle. 5 is supplementary to 6, 6 is supplementary to 7, so therefore we know that angle 5 is congruent to angle 7 because of the congruent supplementary theorem. Awesome. Next page. Okay, here's example 3. So, which previously proven theorem is used in example 3 as a reason? Step 4, right here, is the congruent supplements theorem, and that was used in example 4. Okay, I'm going to push pause and go back to the next slide. Okay, here's some you tries. I'm asking you to push pause and work through these. These are the type of problems you'll see on quizzes and tests and homework, and I need to make sure you can do them before we move on. So go ahead and push pause. You're using vertical angle. Make sure I get the wording right. The vertical angle congruence theorem or the linear pair postulate. So go ahead and push pause. The great thing about this new theorem we've learned, we actually only have to solve for one angle and then we've got the rest of them. So in this first example, the measure of angle 1 is 112. So I just redrew I didn't draw any arrowheads, the intersecting lines, plugged in the 112 here. So I know this one was 112. I know these are supplementary, so I can do 180 minus 112, 68. So I know this one's 68. I solve for one angle, I've got all four. Same here. Measure of angle 2 is 67, so I took 180 minus 67 and got 113, so I know 113, 67. Pretty simple. Go back one more. Another you try. Which previously proven theorem is used in example 3 as a reason? If we go back here, congruent supplement theorem. Example 4. Which equation can be used to find x? I have 32 plus 3x plus 1 equals 90. 32 plus 3x plus 1. 90 is a right angle. Okay, I have not at a right angle here. 32 plus 3x plus 1 is 180. Okay, TR is a line or a straight angle. So I think that's it, but let's go ahead and look at the other ones. 32 equals 3x plus 1. 32 equals 3x plus 1. This is the one you guys want to use all the time, but it is not correct. Okay? They are not equal. They don't even look equal. Not that we could ever use that as a reason, but they don't even look equal. And 3x plus 1 equals 212. I don't even know what that one means. So B is your answer. You try. Use the diagram in example 4. Solve for x. Okay, this isn't saying to show your reasons, to write it like a proof. It just wants you to solve for x. So go ahead and push pause. There you go. Next. Use the diagram. Find the measure of angle TPS. Push pause. There we go. We already knew that x equaled 49. So I solved for this angle measure, and then we know that this angle and that angle are vertical, so they're equal. Okay, here's your daily homework quiz. I'm going to write in the responses, and I would just go through the steps and make sure you understand. Next page. I'm pushing pause. Well, there we go. That's it. Good job. See you guys tomorrow.